a mysterious object recently captured the world's attention as it raced through our solar system. Shining brighter than expected and behaving unlike any typical space debris, it defied the usual laws of gravity, particularly as it accelerated near the sun. Scientists were left stunned by this anomaly, which they named Oumuamua. Its strange movement and trajectory sparked serious concern, as it appeared to be heading toward Earth. While there's no certainty of an imminent threat, the idea of a returning alien probe, or something even more powerful, has stirred widespread fascination and caution. When Oumuamua was first detected, one of the main questions scientists wrestled with was whether it was a comet or an asteroid. These two celestial types differ significantly, despite both orbiting the Sun. Comets, made largely of ice, dust, and rock, tend to release gas and form glowing tails when heated by the Sun. Their orbits are usually long and elliptical, bringing them from distant parts of the solar system. In contrast, asteroids are composed mostly of rock and metal, usually reside in the asteroid belt between Mars and Jupiter, and don't exhibit tails because they lack the volatile ices needed to vaporize. Oumuamua, however, did not display the signature gas emissions or tail typical of a comet. And while it resembled an asteroid in appearance, its odd acceleration didn't fit neatly with known asteroid behavior either. This ambiguity made it one of the most intensely studied and perplexing objects in modern astronomy. The odds of spotting something like Oumuamua are astonishing when you consider how vast space is and how recent human astronomical technology really is. Stars can live for billions of years, and even solar systems take hundreds of millions of years to form. Yet humans have been observing the cosmos with telescopes for just around 400 years. Until recently, we lacked the tools to detect fast, dim interstellar travelers. That we even noticed Oumuamua could be attributed to either incredible luck or, perhaps, that it was meant to be seen. The object's origin remains unknown, but there are clues. Stable, mature solar systems like ours typically don't eject large debris into space. Instead, younger systems with more chaotic gravitational dynamics, such as those involving collisions or planetary migrations, are more likely to fling small bodies into interstellar space. It's believed Oumuamua might have come from a system with a planet similar in mass to Jupiter. Such a giant planet could gravitationally hurl smaller objects outward. However, not all systems form these Jupiter-like giants. Many form what are known as hot Jupiters, massive planets that orbit very close to their stars, making them less capable of launching objects into the void. Neptune-like planets, often found on the outskirts of solar systems and comparable to our own Kuiper Belt region, could also influence these dynamics. Yet, detecting these kinds of distant planets in other systems remains difficult with our current technology, which favors spotting large planets close to their stars. One theory that intersects with the mystery of Oumuamua is panspermia, the idea that life can spread across the universe via celestial bodies like comets or asteroids. In this view, Oumuamua might carry microscopic life forms, possibly seeding other worlds. But so far, no evidence supports the notion that it carried life. After years of study, the consensus among many scientists is that Oumuamua is most likely a comet, albeit a very unusual one. One theory suggests that its odd motion could be explained by frozen hydrogen on its surface reacting with sunlight. As it neared the sun, the sublimation of hydrogen may have caused it to speed up, slightly altering its path. Its reddish color also supports this theory, suggesting prolonged exposure to cosmic radiation. To learn more, astronomers proposed Project Lyra, a bold plan to send a spacecraft to intercept Oumuamua. Although the object is now far away, it's still possible to catch up using a clever maneuver that involves swinging around Earth and Jupiter to gain the needed speed. If it succeeds, the mission would become the fastest spacecraft journey ever undertaken. The probe would first use Earth's gravity to gain momentum, slingshot past Jupiter for another boost, then return near Earth for a final push, catapulting it deep into interstellar space in pursuit of Oumuamua. Another intriguing visitor from beyond our solar system is Borisov, named after the amateur astronomer who discovered it in 2019. Unlike Oumuamua, Borisov has provided scientists with a longer window to study it. Analysis shows it emits a steady stream of dust, over 400 pounds per second, and contains significant levels of carbon monoxide, indicating it formed close to its star before being ejected. Its relatively unaltered condition suggests it hasn't interacted with other stars. This could hint at the presence of a large, undiscovered icy planet far beyond Neptune. Speaking of distant celestial bodies, astronomers have been trying to locate a mysterious Planet 9, also known as Planet X. Mapping efforts from a telescope in Hawaii have narrowed down nearly 78% of the potential areas it could be hiding in. Planet 9 is theorized to be a gas giant about 10 times the mass of Earth, orbiting the Sun at a distance 29 times farther than Neptune. If it exists, it would take between 10,000 and 20,000 years to complete a single orbit. While no telescope has yet captured a definitive image, the theory is based on the unusual alignment of distant objects in the Kuiper Belt. The orbits of at least 6 such objects are strangely aligned and tilted compared to the rest of the solar system, a coincidence with a probability of just 0.07%. This oddity suggests that a massive unseen planet could be influencing them. Early skepticism about these theories has softened with new studies, including one in 2017 by Spanish astronomers who examined distant trans-Neptunian objects for signs of gravitational disturbance. Their work suggested a massive planet lurking 300 to 400 times farther from the Sun than Earth. Historically, similar orbital anomalies led to the discovery of Neptune after scientists noticed Uranus wasn't behaving as predicted. Now, new calculations suggest that if Planet 9 does exist, it may orbit the Sun every 7,000 years, not quite as far as previously assumed. There's now a 99% probability that the alignment of distant Kuiper Belt objects is due to this planet and not a random occurrence. Optimism among astronomers has surged, pushing forward the development of new tools to hunt for it. Among these tools is the Vera Rubin Observatory in Chile, expected to begin operations in late 2025. Equipped with the world's largest digital camera and a 27-ton telescope, it will scan the southern hemisphere sky every few nights for the next decade. Its mission is to catalog all observable objects beyond Neptune, including asteroids, comets, and, possibly, Planet 9. Still, not everyone agrees on the existence of Planet 9. Some scientists argue that a cluster of smaller celestial objects could collectively influence the observed orbits. Others propose a far more radical idea, that the gravitational pull might actually come from a small black hole. An even more unconventional theory suggests that our understanding of gravity itself could be flawed. According to modified Newtonian dynamics, distant icy objects might be influenced by the overall gravitational field of the Milky Way, rather than a single large body. While none of these alternatives have been confirmed, they underscore how much we still have to learn. Interestingly, there's even talk of a hypothetical Planet 10, a smaller object potentially the size of Earth or Mars, sitting at the edge of the Kuiper Belt. However, if it's too small to clear its orbit, it may not qualify as a full-fledged planet, similar to how Pluto was demoted in 2006. Meanwhile, Earth is undergoing its own changes. Our planet's magnetic field has been weakening over the past 3,000 years, and this trend may lead to a magnetic pole reversal sometime in the next 1,000 years. During such a flip, Earth's protective shield could diminish, exposing us to higher levels of cosmic radiation. This could disrupt satellites, damage electronics, and pose health risks. Scientists are closely studying a region called the South Atlantic Anomaly, where the magnetic field is particularly weak, about a third, the strength found at the poles. Data from satellites is helping researchers understand this anomaly and how Earth's magnetic field might evolve in the future. Looking further ahead, our galaxy itself is set for a dramatic transformation. In about 4 billion years, the Milky Way will collide with the Andromeda Galaxy. Despite the magnitude of this event, the vast distances between stars mean direct collisions are unlikely. Instead, stars, including our own Sun, will be redistributed into new orbits within a merged galactic core. Earth will likely remain intact, albeit in a very different part of the universe. Turning our eyes to Saturn, its iconic rings are slowly disappearing. A phenomenon known as ring rain is drawing ice particles from the rings into Saturn, pulled by the planet's magnetic field. NASA estimates that enough water is lost every 30 minutes to fill an Olympic-sized swimming pool. At this rate, Saturn's rings could vanish in about 300 million years. Some theories suggest these rings formed relatively recently, perhaps less than 100 million years ago, possibly from a moon collision or a disrupted comet. Finally, humanity's future also invites speculation. 1 million years ago, Homo sapiens didn't even exist. As Earth's population grows and resources become strained, future humans might evolve to be smaller for energy efficiency. Or we could integrate more technology into our bodies, evolving into hybrid beings.